Okay, here's an interesting derivative. Let's find the derivative of x to the power of x. So the derivative of x to the x. So what we could do here is we could write y equals x to the x, and we're looking for find dy over dx. Find the derivative of y. Okay, so we could apply logarithmic differentiation. So let's take the natural log of both sides of this equation. So we'll have the natural log of y equals the natural log of x to the x. This seems like a good choice because it allows us to bring the exponent out front. Okay, so we have the natural log of y is equal to x times the natural log of x. Okay, this is a much more manageable situation. It's a product, and we have a product rule for derivatives. Okay, so we could take the derivative of both sides of the equation. The derivative of the left is equal to the derivative of the right. So the derivative of natural log of y should equal the derivative of x times the natural log of x. Okay, on the right we have 1 over y, that's the derivative of the natural log function, and applying the chain rule, times the derivative of the inside, which is dy over dx. Okay, and on the right we have the product rule. So we could take the first times the derivative of the second. So x times the derivative of natural log plus, now let's switch it up, the derivative of the first, which is 1, times the second, which is the natural log of x. Okay, looks like here the x's cancel. So x times 1 over x, that equals 1. So we have 1 over y times dy dx is equal to 1 plus the natural log of x. Now let's multiply both sides by y. So I'll isolate the dy dx. So dy over dx is equal to 1 plus the natural log of x, 1 plus the natural log of x times y. And y is equal to x to the power of x, so that could go in here for this y. So dy dx, the derivative of x to the x, is equal to 1 plus the natural log of x times x, should be blue, times x to the power of x. Okay, that does it for this one.